బుక్లో దాంతో
సేమ్గా రాలేదు సార్.
సేమ్గా రాలేదా? రెస్పాండ్. సగం సగం చెప్తారేంటి?
సేమ్ వాల్యూస్ రాలేదు సార్.
సేమ్ వాల్యూస్ రాలేదు. ఓకే, I will check that calculator. I will try it once and then I will tell you after that. No problem. It's okay. Come on, we start unit number 5. It's all about compensators and controllers. Compensator. What does it mean the compensation? In general mean compensation means do you have any idea about it? Compensators. Yes or no?
No, sir.
No.
Giving money.
Compensate చేస్తున్నాము. Yes. Yes, somewhat. Yes, correct. Go ahead. Sushma.
Giving money in recognition.
Giving money in? నీకు నెట్వర్క్ ఇష్యూ ఉందా నీ దగ్గర? ప్రాబ్లం? ఎనీ ప్రాబ్లం? ఎస్, ఓకే దెన్. కంపెన్సేషన్ అంటే ఏంటి జనరల్గా? Anisha, I think all of you guys are from English medium only, so you can tell. என்னமா? Any other? Janapriya, you are saying something? Grishma, Nava? Nashtaparihara, very good. Janapriya. Nashtaparihara. Okay, an example.
Accidents అయినప్పుడు.
Okay, you got experience somewhere else, I think so. Yes, carry on. Janapriya. Continue. That's fine. Correct only. Yes, continue. Respond.
యాక్సిడెంట్స్ అయినప్పుడు నష్టపోయిన వాళ్ళకి వేరే వాళ్ళు ఇచ్చేది సార్.
అంటే గుద్దిన వాళ్ళు ఇస్తారనమాట, రైట్?
ఎస్ సార్.
ఓకే, దట్స్ ఫైన్. ఎనీ అదర్ ఎగ్జాంపుల్స్? గ్రీష్మా, నోవా?
ఎస్ సార్.
ఎస్, రెస్పాన్స్ సార్. Tell me an example. Nashtaparihāram, she said clearly. Compensation. So any other examples in your way, in your own way? Your experiences, sir. Nashtaparihāram. Okay, that's fine. Anybody? Dattu, 65? 68, Priya?
Yes, sir.
Yes. Any examples from you?
Yes, sir. Natural calamities వచ్చినప్పుడు sir.
ఏంటండి?
Natural calamities వచ్చినప్పుడు లాస్ అయిన పీపుల్ కి కాంపెన్సేషన్ ఇస్తారు.
I'm not getting clearly. ఏం parameters?
Natural calamities అంటే earthquake.
Yeah, natural. Yeah, okay. Natural calamities. Yes. Earthquakes, floods, like that.
And governmental issues అంటే గవర్నమెంట్ బిల్డింగ్స్ ఏమైనా కొలాప్స్ అయినప్పుడు.
ఓకే, ఎవరైనా సఫర్ అయితే కనుక వాళ్ళకి కంపెన్సేషన్ కింద మనీ ఇస్తారు, రైట్?
ఎస్ సార్.
వెరీ గుడ్, సూపర్. ఎనీ అదర్? గ్రీష్మా, ఐఎమ్ ఎక్స్పెక్టింగ్ ఫ్రమ్ యూ at least one answer. Are you there? Are you there?
Yes, sir.
Yes, respond. Next, Sushma, she said 78 Rakesh. 78 Rakesh. Okay, if I'm asking the question simply one by one left, what is this nonsense here? Bhargavi, are you there? Yes, 84. You can also respond. Bhargavi,
Yes, sir.
any example? Think of it, guys, all of you. Compensation. మీకు ఏమైనా ఎక్స్పీరియన్స్ అయినా సరే, that's it. Here we needed that word. That's it. The word compensation is the main topic in this 15. Yes, Bhargavi. 97. An example. Nageshwar. Say yes or no if you want. If you don't want to say, just no. Say no, that's it. Don't delay. Yaar. What is the use of that? Useless things.
Life insurance.
See not? Yes. Life.
Insurance.
LIC. Or any other policies. Explain it to your friends. Krishma. See not? Respond man. Yes, see not also Sushma. Yes, you can respond. See not? Tell me clearly. Samyukta, are you there? A3. A3.
Yes, sir.
Yes, respond. What is compensation? Have a shop?
Yes, sir.
యా ఇప్పుడు చెప్పు కంపెన్సేషన్ ఏంటో.
Class వస్తే
ఏంటి?
లాస్
లాస్ లాస్ వస్తే
ఏదైనా ప్రోడక్ట్ కి లాస్ వస్తే
ఓకే.
అప్పుడు నష్టం.
వాయిస్ క్లియర్గా రావట్లేదు, కొంచెం పెద్దగా మాట్లాడు. ఏదైనా ప్రొడక్ట్ లాస్ వస్తే కనుక ఏం చేస్తారు? కస్టమర్కా లేకపోతే మీకా?
మాకు వాళ్ళకి ఇద్దరికి.
ఇద్దరికి ఎవరు భరిస్తారు?
మాకు వస్తే మేమే చూసుకోవాలి, వాళ్ళకి వస్తే మాదే.
ఓకే, వాళ్ళకి వస్తే మీదే బాధ్యత, రైట్?
సార్ మాకు వస్తే మేమే భరించాలి.
ఓకే, వాళ్ళకి కస్టమర్స్కి వస్తే ప్రాబ్లం. సపోజ్ ప్రొడక్ట్ ఏదో సంథింగ్ అంటున్నారు, వాషింగ్ మెషిన్ అనో ఫ్రిడ్జ్ అనో సంథింగ్,
రీప్లేస్ చేస్తాం.
రీప్లేస్ చేస్తారు. సో రీప్లేస్ చేసినప్పుడు అది మళ్ళీ మీరు పైకి ఫార్వర్డ్ చేయరా కంపెనీకి?
వాళ్ళు తీసుకుంటే చేస్తాం, లేదంటే అది లాస్ అయిపోయింది.
అచ్చా. సో వాట్ ఇస్ ద బిజినెస్ దేర్ ఇన్ ఒంగోలు?
సార్
మీరేంటి బిజినెస్?
షాప్ సార్ నార్మల్.
కమ్ టు దేర్ టుమారో. A6. Manisha, Manisha. Yes. Any example from you?
హోటల్లో ఫుడ్ బాగోకపోతే ఇంకో డిష్ తీసుకొచ్చి కంపెన్సేట్ చేస్తే
బాగా ఎక్స్పీరియన్స్ అయినట్టుంది. That's correct. Okay. Likita, what about you? A0, 99. You can respond anyone. Dakshayani, are you saying something? Okay, Tanmay, A0. Mara, Tanmay. Mic not working. Okay then. A2, Likita. A2. Mara, Likita, A2. A9, Vamsi. Vamsi, are you there? B0.
Sir,
An example.
bonus, sir. కంపెనీలో బోనసెస్ ఇస్తారు కదా.
బోనస్ అనేది ఎక్స్ట్రా బెనిఫిట్, దట్ ఇస్ నాట్ కంపెన్సేషన్, ఐ థింక్ సో, రైట్? బోనస్
ప్రాఫిట్
అనే, సారీ,
ప్రాఫిట్ షేరింగ్ సార్.
మా ప్రాఫిట్ షేరింగ్ అనేది అది ఎక్స్టర్నల్ థింగ్, అది కంపెన్సేషన్ ఎలా అవుతుంది? అసలు కంపెన్సేషన్ వర్డ్ అనేది ఎప్పుడు వస్తుంది? ఏమన్నా ట్రబుల్ అయినప్పుడు మాత్రమే కంపెన్సేషన్ అనే వర్డ్ వస్తుంది, రైట్? ఫస్ట్ పర్సన్ చెప్పారు యాక్సిడెంట్ అయితే, సో దే ఆర్ సఫర్డ్ బై అస్, or whatever may be the situation. And one more person said that floods. That means you are suffering there. At that time only the compensation word will come to the picture, isn't it? Profit అనేది it's a different thing. It is extra benefits actually. It is not under compensation, isn't it? Yes or no? Sushma?
Yes.
Are you, yeah. Do you not? Bonus is not comes under compensation, right? Right. It's extra benefit. Yeah, any other? Ashita. Okay. P6 Anil, do you have any idea? Any example? Anil.
Okay.
No, simply no. You are a farmer background, right?
Okay.
Then you have to say at least one example. I think you faced it. Okay, next B7. B7, can you say an example? C1, C5, C8, you three guys. 38, 40 members నుంచి 30 వచ్చారమ్మా, సింపుల్గా. It's okay, it's bad thing. C1, are you there? C1, C5, Akhil, C5, C8, Rishita, Amara. Okay, that's good. It's okay then. Let me start my fifth unit. Unit number 5, ma. So compensators, controllers, and state space analysis. State space analysis. Unit number 5. Compensators, controllers, and state space analysis. So basically, we'll go for the compensators first, and then controllers, and then state space analysis. Hardly I will take maximum 7 to 8 classes only. So try to focus on first 4 units better. And if you want, anybody wants, you can go through this also. It is easy, but more number of topics are there. It depends on you. It doesn't matter. Okay, is the screen is Bima? Please respond.
Yes, sir.
Yeah, okay, done. So now done first compensators and controllers. Put a heading there, and then copy this all the theory part. The main purpose is whenever you have the system is unstable, at that time you need a compensator or controller. You will have the question like this. Suppose if the system is unstable, we can go for another system. If again that system also unstable, we will go for another system. So keeps on, if you are going like this means, it will make you the waste of time, waste of cost, and waste of infrastructure or maybe. So for that, to avoid all these situations, whenever if the system is unstable, simply we will go for some other circuits inside of that system. That means we are going to replace or we will add another circuits to that system to make unstable to the stable. That means to convert that unstable system to stable system. So at that time, at the type of cases, we'll go for these compensators or controllers simply. Compensation. Okay. If the system is unstable, then we require a compensator or controller to make it stable and to achieve the desired performance. So sometimes even though the system is stable, then also we'll go for the compensators because to get the desired desired specifications. That means whatever you want. That suppose if there is a system, suppose you are applying some inputs here and you are getting you want to get some outputs. That means your required outputs. If you want to get at that time also you need some compensators or controllers in the given system. Okay, some inputs you are going to apply to the system now. Whenever if you want the output is your desired only, at that time also we can apply compensators or controllers to the given system. Isn't it? Is it clear? Compensator or controller, just to make the system is stable and to get the desired output. For these two parameters, we'll go for these compensators and controllers. Okay, note on all these things. So basically we have three compensators are there mainly. So one is lead and another one is lag and another one is lag lead. So these three are the types. And put a heading these compensators. It's simply an electrical network. Electrical network. Electrical network is nothing but it contains passive elements. That means which is contains of poles and zeros. So always remember, some guys are confused about this. Transfer function means simply zeros to the poles now. Zeros by poles. Zeros by poles. Numerator to denominator. Numerator to denominator. D and P. Simply it is DP. Denominator means P. DP. Display picture we call it as in WhatsApp. So D stands for denominator. And P stands for poles. అంటే denominator లో poles ఉంటాయి. Remember like this DP. Okay. Manisha, are you there? Okay, remember like this now. Some people are confusing about this. So DP means denominator poles. Denominator లో ఏమంటాయి poles locations. Poles ఉంటాయి. Numerator లో zeros ఉంటాయి. Transfer function simply. DP. Better to remember this one. DP. That's enough. Okay, next. Not only all these things, no. So second and the material content of theory part and function only. Go through that also. Don't neglect. Please write everything. 14 plots the PPT send చేశాను మీకు సుష్మా సిఆర్ anyone respond send చేశానమ్మా
Yes, sir.
ఓకే ఓకే done. Yes, after completion tell me compensator. Is there any spelling mistakes you can tell me? That general ఈజీగా ఉండడం కోసం అని చెప్పి ఇది టెక్స్ట్ బుక్ లో ఉందో లేదో చూడలేదు బట్ నేను డైరెక్ట్ గా రాసాను. యూ కెన్ గో త్రూ ద టెక్స్ట్ బుక్ ఆల్సో ఇఫ్ ఎనీబడి వాంట్ అండ్ హూ వాంట్ టు ట్రై ఫర్ ద గేట్ డోంట్ నెగ్లెక్ట్ దిస్ యూనిట్ ఆల్సో. Who are willing to attempt this gate exam or course exams, this is also needed for you. Don't neglect.
Completed.
Okay, remaining guys.
1 minute, sir.
Okay,
Completed, sir.
carry on, write it clearly.
Completed.
Okay, next. So let me start this first one, that is lag compensator. Lag means, see, just listen one thing here. Lag lead ఎలా observe చేస్తామంటే whenever pole is near to origin, that is lag compensator. If we have the zero is near to origin, that is lead compensator. I'm repeating, pole is near to the origin, then that is lag compensator. If the zero is near, if the in pole zero plot, if zero is near to the origin, then that is lead compensator. Lead, see this lag and lead. And one more thing, pinpoint answer if you want, you can note down in the side. Lag is nothing but low pass filter, lead is nothing but high pass filter. And here pole is nearer to this one. Pole means negative angle or positive angle. Pole means negative angle or positive. Yes,
Negative angle.
negative angle, very good. So lag means low pass filter, pole is near to origin, low pass filter, and it is negative angle, negative. What about here? Lead means, if you want you can note it down. Lead means high pass filter, zero is near to here, zero is there, zero lead compensator, high pass filter. So zero will give you positive or negative angles.
Positive.
Positive angle. So if you want, you can note down in the side corner of this page, corner of your pages. So make a box there like this better. that will give you some idea about those lead and lag compensators, how the locations and how the angle it is going to be give, and what are these, whether it is poles or zeros. Okay, if it is finished, you can start this lag compensator. So here the lag compensator pole is near to the origin. Now is this completed? Shall I erase this? Yes, ma?
Yes, sir.
Remember these points, ma. Pinpoint for who are preparing for gate. You can. There is a big need for this. Positive angle, negative angle, like that. Yes. Complete this total. So here, pole means minus 1 by beta t, and 0 means it is 1 by t. So this is the real axis sigma and inner axis j omega. Okay. And here beta is greater than 1 only always. Here beta is always greater than 1. So the 0 is located to left of the pole. You know, if beta is greater than 0, then only this pole is nearer to origin. మా ఇందాక కంపెన్సేషన్ గురించి ఒక పర్సన్ చెప్పారు, బీనాట్ ఆర్ సంబడి సే. సో బోనస్ కానీ కమిషన్స్ కానీ అవి కూడా కంపెన్సేషన్ కింద తీసుకుంటారు. బట్ ఎలాగా అంటే, సపోజ్ అందరికన్నా ఎక్స్ట్రాగా పనిచేస్తే ఇట్స్ లైక్ ఓటీ అనమాట. ఓవర్ డ్యూటీ కానీ ఓవర్ టైం చేసినప్పుడు, ఆర్ఎల్స్ ఎక్సెప్షనల్గా ఉన్నారనుకోండి పర్సనల్, దట్ మీన్స్ కంపేర్ టు అదర్ హీఈస్ ద టాప్ ఇన్ ద సెన్స్ ఇన్ టర్మ్స్ ఆఫ్ వర్క్, ఇన్ టర్మ్స్ ఆఫ్ పెర్ఫార్మెన్స్, లైక్ దట్. At that time they will give some money or some any other posts or like that. That type of situations also you can call it as compensation. I just came to know that compensation at that time also. So but companies lo frequent ga bonus ani every year istuntaru, that is not comes under compensation. If they are going to give any one person exceptionally, at that time they will call it as this compensation. Bonus anedi frequent ga any company or any institution or any other factories also they will give year wise. అంటే పండగలు వచ్చినప్పుడు లైక్ దట్ సీజనల్గా ఇస్తుంటారు. సీజనల్ ఏదైనా పండగలు వచ్చినప్పుడు లేదా కంపెనీ స్టార్ట్ చేసిన రోజును అట్లా బోనస్ అనేది ఫ్రీగా ఇస్తుంటారు అనమాట. దట్ ఈస్ నాట్ కంపెన్సేషన్ యాక్చువల్లీ. అది నష్టపరిహారం కింద రాదు. కంపెన్సేషన్ ఎగ్జాక్ట్ వర్డ్ ఏంటి? నష్టపరిహారం అనో, పరిహారం, ఎనీ అదర్ పరిహారం. తను 77 చెప్పారు కదా నష్టపరిహారం. మీరు కంపెనీ ద్వారా మీరేం సఫర్ అవ్వట్లేదు, బట్ దే ఆర్ గివింగ్ బోనస్ మీన్స్ దిస్ ఈజ్ ఎక్స్ట్రా. దిస్ ఈజ్ ఫర్ యువర్ sacrifice and for your hard work they are going to pay, not నష్టపరిహారం. కంపెనీ ద్వారా మీరేమన్నా సఫర్ అయినప్పుడు దట్ వర్డ్ కమ్స్ ఇన్ టు ద పిక్చర్. Ashita, you said some bonus or something is there. That is also sometimes it is correct if only for one people are there. That means exceptional fellows are there. They will give some particular positions or money to that particular fellow only. Compensation. Yes. If you see here, so the transfer function of lag, basically it is zeros by poles ma. See here, Z stands for zeros and P stands for poles. And this suffix C indicates compensation ma. This suffix C indicates compensator or compensation. Compensator. So it is poles zeros location by poles locations, and always beta is greater than 1. Beta is always greater than 1. So the zero of lag compensator is ZC is 1 by T. And what about pole ma? Pole is 1 by beta T, PC. So from this equation 2, can you tell me T? What is T here? What is T here, Ashita? From equation 2, what is T? Anisha, are you there? Is there any network issue now? Yes, T equals to
1 by ZC.
1 by ZC. Very good. What about from the equation number 3, beta?
T into PC. By T into P.
Yeah, 1 by
T into PC.
Very good. What about T again? T can be replaced by
1 by Z.
1 by beta.
1 by beta only.
Sorry, sir.
Okay, next again you can replace in any other form. You can take this ZC to upside. Yes. ZC by PC. So T is nothing but 1 by ZC and beta is nothing but ZC by PC. 0 by poles. Zeros to the poles. So beta is a factor here. Beta. Yes. Has this completed?
Yes, sir.
So we'll go for the realization of lag compensator. That means how it looks like in electrical network form. How it is looking like. That means based on RLC components, we are going to design that. It's a simple network. So here it is. The realization of lag compensator using electrical network. So ఇవన్నీ థియరిటికల్ అడుగుతాడంటే there may be no chances. There is no chance at all. But you need some explanation here. That's why I wrote all these things. And one more thing, guys, please wait. Tell me one thing here. In terms of impedance, how to write this resistance? How to write this resistor? Similarly, inductor. Similarly, capacitor. Resistor means impedance is R. What about inductor? L can be written as JWL, and also you can write it as SL. What about capacitor in the same way?
1 by j omega
1
c.
by j omega c.
Very good, ma. 1 by j omega c or else? Or else? 1
1
by?
by sc.
Very good. So 1 by sc. So directly I am replacing here 1 by sc ma, instead of writing all these capacitors on 1 by. Okay, now note down. So here input is Ei and output is E naught. Let me consider like that, or else your wish, whatever. So remember these words, ma. These also used in EMTL also, even in EMTL, ECA, and in all the next feature stems also you have to use this impedances. How to write these passive components in terms of impedance. Okay, so by voltage division rule, so output is nothing but input is multiplied with output side parameters and the voltage across where you are finding those parameters. Output parameters divided by equivalent impedances. Equivalent impedances. So see here, output we are finding with respect to from this terminal to this terminal, this terminal to this terminal. So in this, there are two components are here. One is resistor and one more is capacitor. Is these two components are in series or parallel?
Series.
Series. Series means we can add or we can do any other combinations.
Add.
Add.
Add. Addition. Addition means R2 plus 1 by
1 by s.
SC. So that's what I did here, ma. So input output voltage equals to input is multiplied by output parameters. Those are in series. That's why I added here R2 plus 1 by C whole divided by equivalent resistance. Equivalent means like this. All the equivalent resistance, impedances. Whatever the impedances are there, that means whatever the components are present in this electrical network, you can add all those in a series form. That means R1 plus R2 plus 1 by SC. And then do rationalization and some all these bhajana here. That means take LCM. Here also take LCM and then do some bhajana here. You will get some answers like this. So do up to here. Do this. Do it fast now. Up to here. So here SC and SC gets cancelled. So remaining term is here. So after completion, up to right here, ma, and then tell me. Up to right here, and then tell me. Try to practice now itself. So, next class, or ఏంటండి
Coding, sir.
కోడింగ్ బి సెక్షన్ ఓకే ఆఫ్టర్నూనే కదా మీకు ల్యాబ్
Yes, sir.
ఓకే దెన్ Yes, completed అండి. The transfer function is nothing but output voltage by input voltage. So the same thing I wrote here. Now tell me one thing here, no? So I want to change this in terms of S plus, means in this form. In this form, I want to change S plus ZC by S plus beta, S plus Z by S plus P, whatever it may be. So ఈ ఫార్ములాకి మార్చాలంటే which term I have to common here. I need to take some terms here to out from this equation. So here also, what are those factors you have to take out to form like this? Yes,
CR2.
very good. Excellent. నిన్న సి సెక్షన్లో ఒక 5 minutes దీని దగ్గర కూర్చున్నాను, ఒకరు కూడా రెస్పాండ్ అవ్వలేదు కనీసం. థ్యాంక్స్ అలా. ఎస్, కమ్ అగైన్. న్యూమరేటర్లో ఏం తీయాలి కామన్? CR2. వెరీ గుడ్ మా. సో CR2 కామన్ తీస్తే ఏమవుతుంది? Here it is
S plus 1 by
S plus 1 by CR2. That's it. మనం ఇక్కడ ఏమైతే కామన్ తీస్తామో ఇక్కడ సింగిల్ వన్ కాబట్టి యాజ్ ఇట్ ఈస్ యూ హ్యావ్ టు టేక్, రైట్? సో even if you take this to inside, the same thing you will get. Compare like that. మీరు కరెక్టా కాదా చెక్ చేసుకోవడానికి అగైన్ మల్టిప్లై చేసి చూడండి. If you get the same thing, that is correct. If not, check again. Very good. Yes, డినామినేటర్లో ఎవరో రెస్పాండ్ అయింది?
C into
C into R1 plus R.
C into R1 plus R2. So ఇక్కడ
S plus 1 by C into R1 plus R2.
very good. So S plus 1 by C into R1 plus R2. Very good. ఎవరో రెస్పాండ్ అయింది? Very good, guys. So is there any cancellations will be happen? Cancellations, C and C gets cancelled and take this R2 to downwards now. R2 ని డినామినేటర్లో తీసుకొస్తే ఒక ఫార్మాట్ లాగా వస్తుంది. సో రిమైనింగ్ టర్మ్స్ S plus 1 by CR2 by, if you take that to denominator, R1 plus R2 by R2. Correct? The remaining term 1 plus, sorry, S plus 1 by C into R1 plus R2. That's it. Just small changes. So take this R2 to here. CC gets cancelled ma here, right? All are here is multiplication only. Antanama. So next, the transfer function basically is like Z plus S plus Z by S plus pole. So here lag means pole is near to this one. That is 1 by beta t. So that now we'll compare this and this, equation number 1 and equation number 2. Compare 1 and 2. This is 2, assume, and this is equation number 1, and compare 1 and 2. So now E naught by S becomes 1 by beta into S plus 1 by T by S plus 1 by beta T, where T stands for, if you compare these two, T stands for, what is the T there?
CR2.
CR2. T is nothing but time constant now. T is nothing but time constant. T or tau you can write. Either you can write T or in some textbooks they may write like this, tau. Both are same, don't confuse with that. Simply tau is nothing but time constant, that is R into C. By default, T is nothing but R into C, if there is RC network. Okay, what about beta? If you compare beta, what is beta there? R1 plus R2 by R2. That is simply factor. Okay. Beta is R1 plus R2 by R2. So this is all about this realization using electrical network. So obviously beta is always greater than 1. always beta is greater than 1. You should maintain like that. Beta is greater than 1. Yes, completed. Huh? Here. అయిపోయిందా అండి?
Yes, sir.
Yes. One more simple thing is this frequency response. That means you have to find the magnitude and phases here. So this we'll see in the next class, no? So maximum, I think I may take afternoon session also if possible. So let me take that in morning section and this section same attendance or change it. Let me stop my presentation. Count 30. Super.